Alright, this is lesson 2.5 of our Precalc 11 class. Unit 2 is called Polynomials. Lesson 5 is called Solving Polynomial Equations. What we're going to talk about in this lesson is what is the standard form of a polynomial function and what methods can we use for solving polynomial functions. So the standard form for writing polynomial functions is expressed as such. Some function of x is equal to the leading coefficient, or the nth coefficient, times x to the power of n, where n is just the biggest number in the sequence, plus the second biggest number coefficient times x to the power of n minus 1, all the way down to the last term. Now this, I don't expect you to write or memorize. This is just the full-on mathematical way of writing a polynomial function. Here's more what they're going to look like in our class. So we have 3 examples that aren't in standard form. We can rearrange them in standard form, and then they are over here. Notice the patterns. We have multiple x squared terms, multiple x terms, and multiple terms that I'm going to call constant terms that have no x's attached to them. So we're going to add or subtract each side of the equal sign and collect like terms so that we have one side set equal to 0 and the other side has the x squared term, then the x term, and the constant term. And again, constant term means the term without an x, just a numerical. So we can have 0 equals the polynomial in standard form, or we can have the polynomial in standard form equals 0. Either way is fine. Either way we can call standard form. Take a moment, make sure these 3 examples make sense to you, and I'll move it on. Alright, here's a couple of equations. We want to solve the equations. The first thing we're going to do is write the equation in standard form. The reason why we want to do that is because we want to have some expression equal 0. Because we can multiply 2 numbers together to equal 0 in a couple ways. So once we have this expression, we're going to factor it. And again, factor means the 2 things that multiply together to be the whole expression. So when we say we're factoring this polynomial, which is we're factoring by using greatest common factor, factoring technique we already learned, we have one expression times another expression equals 0. Well, the only way that can be the case is if the first expression is equal to 0, or the second expression, the second factor, is equal to 0. So either x equals 0 or x minus 7 equals 0. If x equals 0, well then that's one solution to the equation. If x minus 7 equals 0, we can add 7 to each side and see that x equals 7. 7 would be a solution to this equation as well. And here we are plugging 0 in for x. Instead of x times x minus 7, it would be 0 times 0 minus 7, which is 0. And if we plug in 7, we get 7 times 7 minus 7, which would be 7 times 0, which also equals 0. So we know 0 and 7 both work, because we checked them in. You don't have to check your answers, but if you want to verify your answers, like on a quiz, it's a good technique. Alright, example B. We're going to solve the equation. We're going to collect like terms, add or subtract to set it equal to 0. We could do that for this one by adding 6 to both sides. Again, to find the solutions, we're going to factor the expression x times x minus 8. And that's going to give us our 2 factors equals 0. If either factor equals 0, we have a solution. So if x equals 0, or if x minus 8 equals 0. Which means 0 and 8 are solutions. So what these 2 examples have in common is that we use greatest common factor to find the solutions. There we go. The next examples will be different. So we have like terms that we can add or subtract from each side to write it into standard form. So our polynomial equals 0. This time we have to factor this thing by inspection. So FOIL method backwards or box method backwards. And we get x minus 2 times 3x plus 2. So if either of those factors equals 0, we have a solution. So we'll set x minus 2 equal to 0, and we'll set 3x plus 2 equal to 0. We'll find our two solutions are 2 and negative 2/3. Well, again, example D, set it in standard form equal to 0. Factor using box method. Set each factor equal to 0, and we have two solutions, negative 1, negative 4/5. So the first two we factor with greatest common factor. These ones we factored using box method. And so now, these ones we're going to factor. We could factor using difference of squares, which was the factoring technique we learned. But I'm going to show you two different ways to do it. One way is, if we set this in standard form, we get x squared minus 81. In other words, when we set this in standard form, we find that we have difference of squares. Because the square root of x squared is x, and the square root of 81 is 9. And we have a minus sign in between. So this can be factored out to be x plus 9, x minus 9, which means if I set these equal to 0, we're going to get negative 9 here. And if I set this one equal to 0, we'd add 9 to the other side, so we get positive 9. So those are two solutions. That's difference of squares. Now what we could do, instead of setting it in standard form, we could set it x squared equals 81, and we could square root both sides, just like we did when we, well, kind of like what we did with radical equations. The difference is, notice that if we square root 81, we get 9. But there's also a negative 9 solution. Positive 9 and negative 9 for both solutions. So to match that, what we do is we put plus or minus the square root of 81. I'll say that in a different way. If I say x squared equals 81, 9 squared equals 81, because 9 times 9 is 81. But negative 9 in brackets squared also equals 81, because a negative 9 times negative 9 is positive 81. So when we square a number, a negative times a negative is still positive, so we have to capture that idea by putting this plus or minus symbol on the numerical square root. So then we can write the answer as x equals positive or negative 9. And this means the same thing, the exact same thing as writing it out. X equals negative 9 and x equals positive 9. Same thing. And you can use the other method. I'm not going to tell you on a quiz that you have to use a certain method. Okay, example F, we can solve. It's not difference of squares. If we add 100 over, we get x squared plus 100, or plus 99, which isn't difference of squares. So for this one, we do have to use the square root method. I'm going to set x squared equal to negative 99, as we're adding 1 to the right side and the left. We'll square root both sides, which means we're going to put plus or minus on the numerical square root. And then if we simplify the square root of negative 99, we get 3i root 11. Again, the negative comes out as an I. We can factor out a 9, which comes out as a 3, leaving 11 in the root. Yeah, it's not difference of squares. How sad. Alright, so takeaways for this lesson. All those methods we use for factoring polynomials, we're going to use them for solving equations. Aren't you excited? Hopefully you have more confidence in factoring and solving equations and working with polynomials in general. Because it's not going away. Oh, excuse me. It's not going away.